Okay, I want to welcome everybody for this lunch seminar series. I'm very happy to see so many of you here today. My name is Alex Bryan. I'm an assistant professor over in civil and environmental engineering in the systems engineering program. I want to thank Infineon for sponsoring this lunch. And for those of you who are watching us from the other CITRIS campuses, Merced, Davis, and Santa Cruz, you can IM us your questions, and they will be read to the speaker at the end of the seminar. I want to make a couple announcements also for CITRIS. On March 16th, there's a talk by Susan Landry on education and technology. In fact, there's a flyer. You can pick it up at the back of the room. And there's also another flyer for Big Ideas competition where there's $30,000 cash prize for proposals that can be submitted through CITRIS. So today, it's my pleasure to introduce Dr. Quinn Jacobson from Nokia. He's the research leader at the Mobile Internet Services Systems team at Nokia Research Center in Palo Alto, where he's currently working on issues to do with a second-generation location-based services. Prior to that, he was working in the Intel's Microarchitecture Research Lab, and prior to that, he was the chief architect for Sun Microsystems UltraSpark 4 family of processors. So he holds a PhD in electrical and computer engineering from University of Wisconsin in Madison, and currently, as a head of the team working on location services at Nokia, he is working on the real-time traffic software on the Nokia part of the Mobile Millennium project. So please join me in welcoming Quinn to this talk.
Thank you very much. I'm also a banana slug, so anyone out there on the Santa Cruz side, that was my undergrad. I'm going to talk about mobile phones here. Nokia, as many of you probably know, is the world's largest manufacturer of mobile phones. And it's been my pleasure for the last couple years to have moved to this domain. Over my career, I guess I started with servers, went down at Intel to desktops and laptops, and now I've come down to cell phones. So I suspect watches aren't far behind. I'm out of business cards, but I'm easy to find. Quinn.jacobson@nokia.com. It's pretty easy to guess my email. And mobile phones are an incredibly amazing system. We have out there today in the world 3.2 billion computers floating around in the world that are basically always connected. And just to think about the potential power out there to observe the world and reach out to the world. They're everywhere, every continent. There's connectivity that is amazing. And with today we're seeing the 3G high bandwidth that is really amazing amount of connectivity. And it travels with each person. So almost every one of you probably has one. These are things that goes with us every day. And they really form this sort of interesting bridge between the digital and physical world. We have a device here that travels with you through the physical world. It has an array of sensors on board that can give it awareness of the physical world. And it's always connected to the internet. It's always connected to the digital world. It can give you information from the digital world. It can share what you're experiencing to the digital world. And that's why I think it's really the most powerful platform we have for a lot of really interesting research. I'm hoping to try to get through my slides pretty quick because I really would like to sort of move into question and answer. So, but feel free as I go to interrupt if you have questions. So the mobile phone today, most of you are familiar with it, but it's good to point out what it actually has in it. It has a cellular modem in it. It can, that gives it voice and data connectivity. More and more, it also probably has a Wi-Fi connectivity. It has a processor. It has compute capabilities. The high-end phones today are, compatible to, in computational capacity, to what a laptop was only a few years ago. Sort of probably a Pentium M class computational capacity is now in your pocket. They have cameras. We actually have, amazingly good cameras. This is the most common camera platform in the world now. And Nokia is actually the world's largest camera manufacturer. has a microphone. So you think about sensors here. We actually have, we have sensors that can detect visual range and audio range. More and more, we're seeing GPS on board. So we have a sense of position, so the device can know where it physically is in the world. More and more phone models now have accelerometers on board. So they can sense orientation, primarily is what we're used for today. But that same accelerometer is quite powerful in terms of sensing other aspects. If you look at activity recognition, the accelerometer is a very powerful sensor to figure out, is someone walking, riding a bike, riding in a car? You can look at the vibrational patterns of that accelerometer, and you can very quickly detect the mode of transportation or many other aspects of activity that the user may be doing. And that's today, the high-end phones, most of them now have a reasonable accelerometer in it. They also usually have Bluetooth, and there's an amazing range of stuff that you can connect to the phone over Bluetooth. Just some interesting examples in the medical field. You can get heart rate monitors. You can get blood glucose meters now that automatically load through Bluetooth. So there's basically, we have a good standard here with a very huge range of other devices that can be connected to the phone. And going forward, if we look at where we see stuff going, the amount of sensors we can have going forward is even richer. Gyroscopes, doing dead reckoning. We were seeing that as we get these MEMS gyroscopes, we can get very accurate, very small gyroscopes in the system. It goes beyond the accelerometers now to get absolute orientation. Weather monitoring. Today you can get at least barometric pressure sensors that are extremely small. Of course, temperature, humidity, but some of these are challenging if you think about it. But if you think about what you could do is if you had 3.2 billion weather stations in the world. It's quite amazing. Unfortunately, it's usually in your pocket, so temperature is very problematic, as is humidity, unfortunately, but there's ways we can get around that. We're looking at also other atmospheric sensing for pollution or other air quality metrics. So you can envision a phone could have detection for various air quality issues. There's been a lot of discussion in terms of sort of detecting either chemical or radioactive agents as sort of a have a mass sensor array out there to look for in case there's a terrorist attack, that we would have the data instantly in the field. And so what we see basically is a transition to this device here. If anyone recognizes the tricorder, yes. We have a device here that can potentially measure anything you ever want to measure. The tricorder could always be pulled out. Whatever it was, they could measure it. And that's really, I think, where we see the cell phones going down the road is there's all this data out there in the physical world we want to measure. There's a number of reasons I'm going to get into here in the next few slides why we want to measure that. But I think we're seeing the direction is we want to build a device, a platform, that as it goes out in the world, you can pull it out and measure anything you want to measure. Why do we want to do that? Why do we have all these sensors? Well, one of the driving things is there's a lot of reasons why we want to collect information for individuals so that we know what you're doing and can give you what you need to do that. I'll go into that a little bit more. And then once you have that information, you have a connected device, you can share that information with select individuals. But the really powerful thing comes when we take this information and we share it, aggregate together globally, and look at sharing not just with your friends, but sharing as a large community, sharing the data that we're locally observing on a device with each individual, and sharing that out so that we can build a global model of whatever it is we were observing in the world. So if we look at these sensors, I mean, primarily what's driving them today to a large extent is the data is used locally. The positioning data, the cameras. What you're doing usually today, you're recording your experience for yourself. You're recognizing, one of the things that we're very interested in at Nokia on the research side is contextual awareness of the device. So that device has these sensors. What can it learn about you? Are you driving? Are you walking? Well, if a phone call comes in, we may want to customize how that's delivered to you based on if you're currently walking or driving. We already have some proposals out there that if you're driving a car, certain calls should be automatically forwarded. You don't want to receive them. So the more the device can use its sensors to figure out what you're doing, what your needs are, the more we can customize both content and behavior of the device to better suit the user. It should recognize, we have this problem. We're in a big room here. It's going to happen today. A phone will ring out loud. It always does. That's no reason it should do it. The phone should recognize you're in a big meeting. You should recognize there's all these people around you. There's a speaker up at the front. I shouldn't ring. I should vibrate. Most of you probably remember to hit the button, turn it to vibrate, but you shouldn't have to do that. The phone device should be have enough awareness to do it by itself. If you look at monitoring your health, a lot of these sensors we talk about in terms of health monitors and stuff, or even atmospheric sensors. A lot of that is, we see a need for people who want to observe their own activity and their own exposure. So they know what they were exposed to. They know what activity level they've had, and if you're watching your weight, or just want to know how active you've been over the past while, you can locally record that for yourself. And as I said, once you record that, you can share that. And the most logical thing to do is share that with your immediate, with trusted partners. Sort of a pairwise or small group sharing of information. And we see that today with some of the services that let you share your location. I want to know where my wife is. She wants to know where I am. We're going to share information. It's a very efficient way. Instead of calling each other, you can just look down. Oh, there she is. And then we see a lot of these stuff where people are using the social networking sites to share more information. What are you doing? What are you feeling? What are your plans? And you can see in the medical field that if I have these sensors where I'm monitoring for myself, I can also share that with my doctor. And so for either an outpatient situation where the doctor says, well, I'd like to watch you for a while, but take this device, Bluetooth it to your phone, go out, go home, do your normal stuff. We'll keep an eye on your measurements as you're out in the world, which is really amazingly powerful if you think about it. The amount of data you can get by putting a EKG on someone and sending them home versus only letting them sit in the office for 10 minutes and run on a treadmill is a lot more information you can get. You can get it for different times of day, after meals, all these other aspects that you can't get in a clinical situation. And of course, telemedicine, so you have someone out there who physically can't get to the doctor but can share readings potentially by a phone. But as I said, what really gets me excited is when we think beyond that. We really think globally. So we have all these people out there. They have a device with them that's aware of what they're doing, aware of where it is. What we can do is we can do implicit recommendations. There's no reason when you go to a town and you're a Cubs fan, they're on and there's a game tonight, you should be able to find which bar you're going to have the most fun at. Where are the most Cubs fans? Because they should have their phones with them. The device should know you're a Cubs fan because your wallpaper in the background is a Cubs picture or whatever, or by what you've locally searched. And you should be able to say, well, I don't care where any individual is. I just want to know where these people with these interests are right now. Or people who, sort of implicit recommendations. So that's one really powerful thing. You can think on these monitoring things. If I do have air quality measuring or any other sort of monitoring, I can build a global data collector through these phones that is orders of magnitude better than anything we have today. And that gives me the initial variable data to drive models that are better than anything we have today. So if you look at, as I said, there are some issues with what you can measure, especially with a device in your pocket. But if the device can detect when it's out of the pocket, take a sample, get the right readings, we should be able to, basically revolutionize weather modeling and other aspects of environmental awareness of our globe. And then, of course, there's traffic, which is what we've been working with Berkeley on, that when you're driving your car, there's no reason you should be surprised by traffic ahead because, of course, there's a bunch of phones up there. They know that they're on the road. They know that they've slowed down. They should be able to tell me so that I can get off the highway and not be the next person to run into that traffic jam. It'd be great. I mean, ideally what we'd like to have is that, these 3 billion phones out there in the world, we put all these sensors on them. We run them all the time. We just stream the data in. Bright researchers here at Berkeley get all that data, and you just mine it and find all this great insight. But there's a lot of challenges why that will never happen. And the challenges we have to solve first so that we can get the benefit. That's what we want. But not at the expense of privacy. We don't want to expose people. So if you think about it, this is a device that travels with you. The cell phone is a very trusted device. You carry it everywhere you go. It's where you physically are. This isn't your profile up on the web page. This is where you physically are right now. It's one thing to get harassing emails. It's another thing to run into someone in a dark walkway at night who is there to cause you harm. So privacy is very real when you're talking about the physical world. So we have to make sure that anything we do where information is being shared, that we understand where the information is going, what is contained there and who can see it, and what can be interpreted from it. And often people don't, because you've got to be careful, because what people don't realize sometimes is what you may be, real safe and don't share the identity with the data, but you got to realize that there's lots of ways that information can be exposed if you're not careful. And so one thing we really, you really need to focus on is, as you're collecting data in the world, to understand what data you're collecting and what data is being stored and what data can be inferred from that. Another issue is battery costs. We all would love to have all those sensors out there, but no one here is going to be very happy if in 2 hours your phone goes dead, because it's doing this glorious thing for research and recording everything about the environment it's in. No one's going to put up with that. And any sensor costs power. And so one of the challenges is, if I am going to collect data from the world around there, how do I do so in an intelligent way that gets the useful bits of data that I care about, but isn't going to just sit there and drain the power of the device? And so you have to start thinking intelligently, what do I measure? When do I measure it? What sensor is really low cost that I can run that sensor, this low cost sensor, and have that trigger and tell me now is something interesting has happened that you may want to power up that more expensive power hungry sensor to take a reading, because I don't want to keep some power hungry sensor on. So instead of keeping my GPS on all the time, I can check and see if I switch cell phone towers. Only then do I need to power up my GPS receiver and check where I am. If I only care about location to some granularity. So you got to think about how you can use these sensors and how you can program for these sensors in a way that's very, very aware of power and network costs. If you're going to move data back, I don't want to stream every reading. I want to figure out what are the readings that are important, that have the most relevant information, and only send that back over the network. Think about an accelerometer. I can take an accelerometer locally. I can do the Fourier transforms on it, try to figure out if you're walking or riding a bike, and then send that as a short little message. Hey, you're walking now. Whereas if I actually send the raw data from the accelerometer over the network, there's a huge amount of information that would need to be transferred to carry that same amount of information, useful information. The quality of the data in terms, I think that's a broader thing as we think about the different data sources we have there. But in general, these are going to be small devices. We're not going to get high-quality, lab-quality sensors. If you're going to be taking, a barometric pressure reading, you're not going to have a highly calibrated sensor out there. What you're going to have is the cheapest, lowest power sensor that we can make. And it's going to give you a reading that has some information in it, but by itself, users aren't going to calibrate. They're not going to go to a lab and take reference measurements. And so any given reading in itself is very low quality. And so when you think about having cell phones out there as a sensor platform, you have to not think about individual measurements. You have to think about having this set of measurements coming in, and how do you correlate them? How do you interpret that data in a way to extract the information, which is there in the data, but isn't going to be there in any individual reading? The integrity of the system, you got to think also, going back to my example, that if this device is aware that, I'm a fan of the Cubs or whatever, pick your team, so I'm a Cal alumni, it's the Rose Bowl, I want to go find the right club. You got to realize the minute you build that system, the first thing that's going to happen is everybody who runs a sports bar has an incentive to game your system and lie. So the minute I build that system, everyone's going to figure out how they're going to generate false data so that they can spoof the system. And so this goes back to privacy, because I don't want to strongly authenticate everyone, because I don't want to have this, sort of system that, authenticates so-and-so is here at such a time and they have certified by this way that they really are a fan. So I'm going to have a system that's going to try, for a privacy standpoint, to strip off as much identifiable information, as much information that can, sort of invasive to your privacy. But at the same time, then I have the problem: how do I authenticate that any of these data I'm seeing is real? Especially, as I said, because a lot of the data is very valuable and will, there's basically has vested interest for people to try to falsify. And of course, none of this is going to happen unless it's useful to the users. We can build the greatest sensors, we can put them in a phone, but unless users see true benefit coming back to them, these are going to be turned off. So the first and foremost thing, and we see this with traffic, we can make putting phones out there with GPS and getting them to give us data back on traffic is really useful to us. But people are only going to turn it on and run it if they see benefit to them as a commuter. And so anything you do that you're expecting data from a community of users, you have to make sure that the incentive is there for the users to want to participate in that system. They want to contribute their data because they're seeing the net benefit of that system. So that's sort of the high-level view. I thought I'd dive down a little bit into the specific example of the work we've been doing with Berkeley on the traffic side, which I think is a good example of how to source data from this array of sensors out there in the world. And so probably many of you have heard of the Mobile Millennium program. The general approach here is to crowdsource traffic data. As I said, you should never be surprised by traffic here. All these cars are sitting here. 98% of them have a cell phone sitting in them. Half of those have a GPS on them. These, so every other car here knows that it's sitting on traffic that's stuck. There's no reason that as you come up the roadway here, you should come around the corner and see this. These other devices share that information. I should be able to know that, exit, avoid the whole problem. The term that within Nokia we use, that sort of is an umbrella term that includes the Mobile Millennium program here, is we call it community enhanced traffic, because it's really that. It's this community of users who are enhancing the traffic data by contributing back what they're locally seeing. The data, we use GPS data as opposed to some earlier work in how to collect traffic data. Is very accurate data. We wanted to make sure, though, that, I'll talk about this a little bit more, that with data we collect from users is all useful, and anywhere we can, it has minimum impact to people's privacy. Of course, we have other data sources to integrate with. So we have today, like here in California, all these inductive coils in the roadway that, of course, be integrated in. And so as these phones out there traveling the world share their information in, that comes in here. That's integrated with other data sources, some of which are very trusted, which helps deal with some of the trust issues, which is something we have in traffic we may not have in other areas. So we can actually calibrate ourselves from independent sensors. And then we have a work here at Berkeley as well as within Nokia on the traffic modeling side here with our NavTech division. And of course, the biggest part of this is you got to get that usefulness back to the users because you have to have the users run the service. And the neat thing about it is the cool thing is it gets better. The more users you get, the better the service gets because you have more data in the system. You can give more rich content back to the users. The problem being, that's great if you're the 10 millionth customer. You have a challenge if you're the 10th customer. So as any of these sort of crowdsourced information, you have to think, how do I deal with the first million users? Not how do I deal with the 10 millionth user. That's actually a lot of scaling challenges there, but we can deal with those. It's actually the other end that's really hard. So as I said, accuracy, efficiency. Let me sort of skip to the punchline here. One of the things we did when we were thinking of this is we wanted to figure out how could I make sure that any data I collected from users was useful and if it wasn't invasive to privacy. So if I ask users to turn on their application, it just pings every so many seconds with where they are. What I'm going to see is your home and your work mostly. You're going to see the origin destination of your travels. That's where you spend most of your time. I'm going to have to filter all that data out, throw that out, to get the information I care about, which is the transit time in between. So what we did is we figured, well, what we do instead is what we care about is when you're on a major road. This is where I want a measurement. So instead of doing a temporal sampling, we quickly realized that the more efficient way to address this problem from both the quality and efficiency standpoint was to do spatial sampling. So what we developed was a system that we go look at the road network, we compute where we want measurements. So not, here's a map. These residential neighborhoods, we don't want any measurements there. These dots show where we want a measurement. But we've computed on these arterial roads going out, these major thoroughfares, and then, of course, the highways is where we do want data. And so basically, we've pre-computed where we want measurements. We basically broadcast that out to the user base. And then as users turn on their device, what it does is it goes and checks. What measurements are we looking for today? The device then, as it travels through the world, figures out, do I have a measurement that's useful, and therefore I can contribute it? And then also has this local privacy rule, so if I contribute this, am I violating any local privacy on behalf of the user I'm representing? And the end system is we get these anonymous reports from users as they travel through the world. Here's a measurement that basically will help your traffic model. One of the things about this sampling model, too, is it's very efficient from building the back end of the system. Instead of having all these measurements flooding us from users that we have to try to sort through to find the useful information, we've basically told the users, these are the measurements we want. We can pre-compute, if I get this measurement in, what can I do with it? And therefore, we can optimize our system so that every time a user comes in with a measurement to us, we know exactly what measurement that is and how we're going to use it in our model. I think this is very broadly to any kind of thing, anything you can do to sort of pre-compute what measurements you want so that as data comes in, I'm only asking users to contribute information that's most useful. Because it's costing them to send that back to me. It's costing me to receive it. So in general, whenever I'm collecting data from the world out there, I want to make sure that anything I can do to pre-compute what data I actually want will make that system more robust. Privacy. There's lots of challenges in privacy on mobile phones. If you think about it, there's one thing to do is say, I just want to collect all the information on users and I'll just try to protect it. And that's fine, but you've got to be really careful. If you think about it, you can inadvertently expose information. Think about the simplest way to do a traffic model. If I don't have any data on a road, I don't show anything. If I get a reading, I'll show that information on the roadway. So if I have one user in the world, I know exactly where he is at all points in time, where he's been. I can look at the map and see where data is showing up for the first time. I can be a little bit smarter and say, well, I'll just leave it in the previous state until I get a new reading, so that I won't show where they currently are. But I can look at where is it changing now. So I could look at the residential neighborhood, everything's the same from the day before, and then suddenly the one user comes through, you see the changes. I can now say, okay, I know that's my user out there in the world, and track them. So you have to really think about the system from the ground up. What information can never be extracted out of the data that is being sent through the system? And one of the interesting things we found in the traffic case, which I can't say definitively, but I truly believe is foundational to any of this sort of crowdsourcing of data from mobile users, is that we actually found that when we started, we thought privacy would be at odds with quality and efficiency of the system. The traffic engineers want more and more data, and then the privacy is basically just saying no. But what we found to some degree was that privacy was actually complementary to a large extent with quality and efficiency of the system. If you think about it, if you think from an from a privacy standpoint, any bit of information I don't need from a privacy standpoint in my end calculation is only an exposure factor. But it's also an efficiency factor. Any information I'm sending to the server that it can't use is it costs, there's efficiency of the system. If you think from a quality standpoint, there's a similar argument. If I have a privacy flaw in my system, it means that one user's activity can be exposed in the outputting model, the outputting data. That's a very severe privacy violation. But it's also a data integrity, data quality violation. Because if one person stops on the road, that doesn't mean the road is stopped. Maybe they had a flat tire. And so you have to be careful from a quality standpoint that no data is ever going to be, one person's anomalous behavior doesn't get exposed to the system as some sort of definitive truth. And so we found that to a large extent, if you start with privacy, we actually think that efficiency and quality will be inherently better in the system. At the loss of information, there's information I have to throw away from a privacy standpoint, and that does cost me in terms of basically future-proofing myself that I may want this data down the road that I didn't know about now when I had collected the data. And of course, you want to service back to the users. So I don't know how many of you have used Mobile Millennium, but you got to get a compelling service back to the users because users aren't giving data to us out of the goodness of their heart. Some are actually. Some of you probably are. This is one of the few crowds I can probably say that actually that's not a true statement. But if you're looking at a normal user, they're not going to put something on their phone that's going to run their GPS, drain their battery for the goodness of their heart to help our research. So if they're going to run it, they're going to want to see benefit. They're going to, what's the benefit? Well, traffic's a pretty easy one. To a commuter, traffic information is useful. It's inherently useful to, so as I leave my house, try to figure out which route to take to work, that information is useful. It has to be in a format I can read. One of the challenges you have with these crowdsources is I get lots of information. How do I filter out, get to the user what's useful to them? And in ways that's useful. So, you have the colored maps, you have audio interfaces, I can have traffic read to me. Ideally, you want to get even farther along and get alerts. Something we're working towards. Instead of just giving you traffic reports, what you want, what you care about as a commuter is, I'm driving down the road. In 2 exits, there's an accident. I should take this exit, get off the highway, so I avoid that. What you want is a machine to come up and basically tell you what to do when it needs to. And that's something we're working on. But there's a large amount of intelligence you have to do to get that confidently so that you can actually tell a user that information. And one of the things you find in any of these systems is you start it and you refine it because, in the modern world of these mobile services, the goal is not to be perfect. The goal is to get something that's useful and compelling out there because only once you have users can you actually figure out what information you are going to collect in what you can do with it. So you have to sort of do it as an iterative approach. And that's where this work with Berkeley on Mobile Millennium has been so useful, is that we're sort of going through this phase of doing a large-scale trial, getting thousands of users, getting a sizable user base, but still in a somewhat early phase here where it's a constantly evolving service. Let's see. This is more historical. I'll skip that. I guess this is an important thing. One of the things we did in our work with Berkeley that has been really useful is that our goal here is to collect data from millions of cell phones out there to do traffic modeling. But we have to do the algorithms of what we're going to do with that data. I'm not going to go get 1 million phones right away. So what do? Well, so what we did was we said, well, if I had the users I expect to have in the future, what would that mean on a given small sample space? So we picked 20 miles of Highway 880 and said, let's say on this 20 miles of highway, I rolled into the future a few years. How many cars on the road would be giving me data? Now I can go create that same situation by basically paying Berkeley students to go drive that road and generate for myself basically a glimpse of the future. And so that's what we did about a year ago. And actually, we started doing it long before that, and we've kept doing it long since then, of taking these, generating for ourselves these little microcosms and trying to run a glimpse of what the future will look like if we have sensors coming in from users. Getting as realistic as we can, the same devices, the same behavior, all of that, but in a concentrated experiment. And so that gives us a data set that we can then go and figure out, scaled up 1 million times larger, what does that mean? And that's great, and as we learned, we've learned a lot from these experiments, but it's only part of the picture, so you have to go to the next level, which has been this Mobile Millennium program, which is to actually, go out and try to get the users. Now, we're not trying to go for 1 million quite yet. We're going for 10,000. But you got to go out there, try to get regular people to use this in a regular way. And that sort of gives the other dimension. I've had lots of users who are out there using it regularly. How do they interact with it? Because if I concentrate my users, I do have, from the user experience, I have non-realistic data. And so that's been the Mobile Millennium program. Anyone who's not familiar with that, traffic.berkeley.edu will get you all the information on that program. But that's a program to try to get phones out there in the world, giving users better real-time traffic data in exchange for them contributing data to us to build that traffic model. And that's the end of the talk phase. I kept pretty good to my schedule here because I really do want to give a good time window here for questions.
I have 2 questions, actually. One is a little detail, which is back in your first slide, you said always connected. And people who are talking about cell phones always say that. I don't know about you, but my cell phone, if I leave it connected to the net, the battery's dead in about 2 hours. So I'm only connected when I'm, running something on the net. And I'm wondering whether my phone is just different from everyone else's or what that always connected means. And the second question is about privacy. If you anonymously collect data about which bars the Cubs fans are at, and if I'm a Cubs fan and I use your service, even though you're not publishing any data about me, the very existence of the service means that people can infer that I'm in one of the top 3 listed sports bars. So that's a privacy problem for using your service, even if I'm not contributing data to it.
Okay, so let me jump on the first. Take the first question first. Always connected doesn't mean always transmitting. Transmitting bits up and down costs a lot of power, but the network is there. The connectivity, the potential connectivity is there. If I have a useful measurement, I can send it. And the cost of maintaining that connectivity now is pretty low. So most people, it used to be with the analog cell phones, you actually had to physically turn the phone off when you weren't using it. Today, you can leave your phone on. It has the connectivity. It's talking to the tower with a heartbeat, and if it has a reading, it can send it. Anyone who runs, push mail and is having constant bit streams coming down does see the cost of actually moving data all the time. The second question, privacy. Privacy is a fascinating field. And it's infinitely detailed. And one of the first things to say about privacy is that, the extreme cases are easy. You can, not give any data to anyone, and basically put yourself on an island. You can have a lot of privacy. You can share everything and be an open book. That's pretty straightforward too. The truth is, we all move on a spectrum. Any service is on a spectrum. You're giving some information in. Some of that can be correlated back to you, some of it can't. Some of it can be correlated by the service provider, some can be to the service other subscribers. But we live in this complicated spectrum, and the services live in this complicated spectrum. One of the things which our challenge is trying to figure out, one, how users relate to that, what are the implications of that. And the greatest challenge, I think, is that the average user cannot set privacy policies. There's been lots of studies that show that users don't understand this. And if you ask them what their rules they want, they never tell you what they want. Some great work out of CMU on this, where you ask people, I'm going to expose your location. Give me a set of rules of to whom and when it's okay. They give you all these rules, and you give them, you actually run it. You let them carry a little device with them, and they find out that no, that wasn't the rules at all they wanted. So users don't understand privacy. It's a big challenge. One of the things, though, I'm a very, very big believer in is that foundationally, you shouldn't collect information you don't need to run that service. That's invasive. And that people see benefit, they're going to share. And it should be an exchange here. And they should be open, and it should be exposed. I'm asking you to give me this information. This is what I'm going to do with it. This is why I need it. And this is what you're going to benefit in return for. But I mean, the fact
even
is
if I don't send you any information at all, by the fact that you're providing this service, somebody who's trying to find me can subscribe to your service, get the listing of where all the Cubs fans are, and with high probability, assume that.
So here's the and this is one of the things. Easy access information is its own risk, but that's information that's there. If you hired a private eye, they could go find which bar was. So I'm just making the information easier. That's the world we live in, where easy information does mean that there is this sort of secondary correlation. I won't argue for or against that.
You were saying that if you had 10 million users out there, it would be very nice for somebody to join, because the data they would get would be useful. Do you have a sense of how many users you need before somebody like me would be interested in subscribing?
Specifically in the traffic case?
Yes, in the traffic, in the Bay Area, say.
Well, in Bay Area, I mean, the beauty of the Bay Area is that we as taxpayers have subsidized a sensor network that already went in. So there's already data available for user number one based on the sensor network that's there. So you don't need me for that. But if I can at least package that data as good or better than anyone else, then I'm at least giving you a benefit.
So how many users do you need to make a distinct difference?
So Alex is really the expert on that, probably the details of that question. And as you know, it's a hard question because it's giving me, there's a coverage and a quality issue. So I can get incremental better quality on a road I already have data on, or I can get some quality on a road I didn't have data on. And it has to do with the Bay Area is a large area, so if I have 100 users who work in Cupertino and live in Mountain View, that's very different than 100 users who live in 100 different locations work in 100 different locations. So I can't give you a single number. What we're doing more is looking for a given thoroughfare, for a given route, for a highway or for an arterial. How many probes per hour or per unit time do I need moving down that road? And then you have to look at these other issues of concentration, distribution to compute. So all we can really tell you is on a given type of road that does or doesn't have existing sensors, what do I need? And the sensors also help in another way. Other than giving initial data, they also calibrate the system. So when I get readings from my probes in an area I don't have sensors, and I get an area I do have sensors, I now have a calibration factor I wouldn't have if I didn't have the initial sensors. So one of the challenges is if I want to go to Mumbai, where I don't have inductive coil sensors in the road, how do I do there? How do I get those first users? Who do I partner with to basically subsidize enough users to bootstrap a system where I don't have a sensor network to start me in?
Yeah. So I know that many car manufacturers are working in trying to improve these navigation systems and these smart grids. Are you working with these manufacturers, or are they developing their own devices, their own grids?
So Navtech, which is a subsidiary of Nokia, works very closely with us in all this. If you're talking about Lexus or Honda in North America, that's where their data is coming from. And so those are our customers. And we're in discussion with them about where does this add value, what data can they add back to us, that kind of stuff. So yes.
So you are leveraging what I have understood from your presentation, that you are leveraging on the mobile phones of the people. But what I'm saying is that these manufacturers are creating, I think, their own devices that connect to the system.
Yeah, and we're seeing that OnStar. Can't remember what Toyota calls theirs, but yeah, we're seeing more and more navigation systems that have their own connectivity potential. The auto industry moves kind of slow, but we are working with them to try to define the next generation there with them. And it's really nice. One of the challenges we have with the cell phone, we talk about traffic, right? Exactly, is I have to do activity recognition well enough. Because in New York City, the guy sitting in the car and the guy on the bicycle, I have to be able to distinguish between them because during one time of day the car is going to go much faster than the bicycle. During another time of day the bicycle goes much faster than the car. If I'm talking to another driver, they don't care how fast the bicycle is going. The nice thing is if it's built to the car, I know a car is there, and it's not a cell phone may or may not be in a car. So then I have this extra burden myself to interpret the data.
I have two questions. The first is that you're talking about sensor calibration, and it seems like if you have, say in the traffic case, you have loops in the road, it seems like you're probably going to want to be able to do on a sensor-by-sensor basis or a phone-by-phone basis a calibration relative to these loops in the road, so that if this driver is off somewhere where there aren't loops in the road, you have more useful information. But that seems somewhat, contrary to the privacy in that you have to essentially pass the user's identity onto, the system that's interpreting the particular data. The second question is regards to, I guess, one of the issues we have in at least the U.S. is that data plans are very expensive, and I'm wondering if you could, say a few words about, what you think is going to happen with that in the future.
Okay, the first question, GPS is a really nice thing in the fact that actually they're very accurate. So I don't need to calibrate the positioning of velocity detection on the client. What I need to calibrate is how to interpret my probe data. So if I'm getting 3 probes per hour in this road, how many cars does that mean is likely moving there? If I have another road that's similar in the same region where I expect my user penetration rate to be about the same, I can calibrate. If I see the loop detector counts 3,000 cars an hour and I see 3 probes an hour, I can kind of do a 1,000 to 1 rough calculation. I can say this road has the same capacity, same characteristics. I should see the same. I can infer the same overall density. So in that case, I'm using it to calibrate how to use the measurements. That's very different than if you look at a barometric pressure reading, because there I'm going to have a sensor that's not calibrated. And so there I'm going to have the situation, I have a user walking around with a sensor that's not calibrated at all. And they're going to be sending me readings, and I can see the ups and downs pretty well, but I do need to work. As they walk by, I have a nice high-quality sensor out there. They walk by that. Should they talk to that local sensor, recalibrate themselves? Or am I just looking at trends and averaging out if I know the distribution of how my sensors work in the world? And there you really do have this problem you discussed where, to some degree, I want people to actively participate in this calibration, which may have a privacy implication. Although there's ways you can do it where you can send the reference out to the user, they can calibrate themselves, as opposed to doing a central calibration. Second question, data plans. Data plans are expensive. The good news is all these technology areas, the trends tend to be always favorable. Prices do tend to come down over time. Competition does work. So we're seeing, we're seeing the percentage of users with data plans is going up at a pretty steady rate, and there is the prices are coming down on average as the number of users go up. We're seeing more and more phone companies that are pushing pushing users. If you get an iPhone, you have to get a data plan. If you have a BlackBerry, you have to have a data plan. So a lot of more users are getting data plans. And there's lots of potential disruptions. If you look at some of the fight over white space and the ability to build sort of disruptive alternatives to big central carriers, there is potential that there's other avenues to move bits that could be cost competitive and with cellular. But the coverage of cellular is a compelling thing, so it's beyond my scope of making any projections.
Do we have any additional questions? I have one question that I get asked all the time is people are asking me what's the next sensor that will go on board the phone, and I feel very disarmed to answer that question. I was wondering if you have any perspective.
What's the next sensor? There's not an easy answer. And what you'll see, like everything else, is we're going to see we're sort of a fun time of playing. So you'll see that some phones will get some sensors, others will get other ones. And we'll kind of let the market decide which ones are compelling. One of the ones we're seeing, is the compasses, Hall effect compasses, magnometers. If you're going to do navigation, orientation is nice to tell the person what way they're actually facing. So that's one of the ones that we've seen popping up on some phones. But we'll see as other sensors come online, and there's a trade-off there, how useful it is, how much power it does, how much it costs. But we're not using all the sensors we have. There's huge potential here. We don't need new sensors. There's a lot of research we can do just with the sensors we have. Just think about the microphone. What we could do by crowdsourcing sound in order to build a model of sound is pretty amazing. You could determine what kind of clubs were where, traffic, wildlife. A lot you could do with sensors we already have, we just are underutilizing.
Your cell phone already has a magnetometer. The model you're using has a magnetometer. The one in your pocket.
The one in my pocket, yes. Actually, no. No, neither of the ones I have actually do. It has an orient.
All the 60 series have a 3D magnetometer, and it has the ST micro accelerometer.
Yes, has the accelerometer. The magnometer is there, but not accessible. Yes, it's physically there. Yes.
Any more questions? Okay, one last, and then we'll have to stop because we're at the end of the hour.
So, for the community enhanced traffic service, for that service to be successful, in terms of network overhead point of view, how much network traffic would it generate? And
well, one of the things is that the network traffic is dominated not by the community enhancing part of it. The traffic is dominated by the user experience, how much data they're downloading to see traffic ahead of them. The data you're contributing, the upstream bits, are very, very low relative to any downstream for you to get information about your surroundings by two to three orders of magnitude difference. By doing spatial sampling, we are only collecting data, so we're not just spewing bits back to the server. We're only taking measurements that we feel are valuable. So we are very efficient, and every bit we collect from users has a value and is worth transmitting.
Those control.
Yeah, I think it is 1 o'clock. So.